Greetings and welcome, friends. We are taking a look at page 160. You guys have been doing equations of, well, yesterday we did parallel lines. Today we'll do perpendicular. Just you wait for the video that'll be posted right after this one. It's going to be amazing. I'm so pumped. But we're talking about kind of parallel lines, things like that. Let's go over some of these homework problems. Here's question 5. This is neither perpendicular nor parallel. This is a directed line segment AB. So I'm imagining from A to B. Let's actually, let's draw this. Why not, shall we? Yeah. Let's do that. So let's see, my largest y coordinate is 6, my lowest one is -3. So I should throw my x-axis, I don't know, let's see, can I hit that 0? I think that's a fake 0. Let's see, so I've got I don't know, somewhere around there. Will I hit 6? 1, 2, 3, 4, 5, something like. There we go. Let's just. So here's my x-axis, something like that. And for my y-axis, where is it at? Let's see. So my largest x-coordinate is 1. My smallest one is -2. I'm just kind of trying to, like, you know, zone in the grid here. So let's see. So 1 to -2. So I'll offset it a little bit, just so that way my image is going to be somewhat centered. You know what I'm saying? You know what I'm saying. Here, let's see. I can even actually make that a little thicker by. There we go. Look at that. Gorgeous. So here's my y-axis. Here's my x-axis. Let's plot us some points. Here we go. A is at 1, 6. So starting at the origin, over 1, up 6, right there. There's my point A. And point B is at -2, -3, starting at the origin, left 2 and down 3. These points are far away from each other. Yes, let's actually even draw that line segment. Man, I love having my ruler, my straight edge tool here. All right, so there we go. Those are my 2 points, and they're asking me, find the coordinates of point P along this directed line segment. It's going from A to B, so it's kind of going backwards in the negative direction for both of those coordinates. Such that A to P, or AP to PB, is the given ratio of 5 to 1. 5 to 1. Okay, so let's talk about that. So imagine point P starts here, and as time passes, it's moving along. And so it's moving along, and imagine that we've divided this kind of into 6 congruent segments. I think I messed up again, didn't I? Whatever, you get the idea. So I divided into 6 congruent segments. Where did I get the number 6 from, friends?
5 plus 1.
5 plus 1 is 6. It's not where I always get it from, but that's where I got it from this time. And so I want the point P to be 5 parts along the way. So this would be like 5 compared to 1 unit that way. All right. And the total distance between those two, or these two components, dividing it up into those portions, is 6. Now this is not units as in like these units, okay? This is in terms of dividing whatever that distance is into these kind of equidistant chunks. All right, so I'm expecting that P is going to be, I don't know, somewhere around here. All right, P, there we go, not B. And I'm just making that up. I don't know where it is yet, but that's what we'll try to get. So what I do is this. 5 plus 1 was 6. So I'm thinking of dividing this into 6 parts. And I am going to be 5 of those 6 parts towards B. Towards B. So if I think about 5 to 6, 5/6 is the fractional amount of the way that I'm completed. I'm just going to communicate it this way as well. You could also imagine that as like I'm 83.3 repeating percent of the way towards B. Okay, so imagine point P, 83% of their journey is complete. It's going to be amazing. I love it. Now, what we're going to do is we've got to think about the movement from A to B. And this is actually similar to vectors, which I don't know if you've seen No, I don't think you've seen vectors. We might talk about them a little bit in chapter 4. So here's a foreshadowing. Let's see. So to go from A to B using only horizontal and vertical motion, I would have moved to the left this far, and I would have moved down vertically, right, this far. Now, if I want to find those dimensions, okay, if I want to find this green distance, what I would do is I would find, let's see, I'm going to do A's x-coordinate minus B's x-coordinate. Is that right? No, I'd have to do B minus A, sorry. So B's x-coordinate, A's x-coordinate, subtract those. That's how I'd find that distance. It's easier to see graphically here if I just count. That's going to be -3 moving -3. So I'm not talking just about distance, but also direction, which is why I'm going to call this -3. How would I have gotten -3 if I was looking at just the coordinates? I would have done -2 minus 1, and I get -3. Okay, let's do the same thing, but for the y, the change in y. So I'm going to take B's y-coordinate, and I'm just making up this notation. I'm just trying to be helpful. If maybe more notation is less helpful, who knows? And I'm going to subtract those. So I'm going to do -3 minus 6. And that's equal to -9. And notice if I go to count these boxes, I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going down 9 units. Okay, now here's a property that we've got for our point P. It turns out if I can find out what 83.3% of this -3 is, I don't know, maybe it's there, and go down 83.3% of -9, I will get a similar triangle. We'll talk about similar triangles later in this course as well, okay? That linearly is 83.3% of, why are my undos doing there? There we go. It's 83.3% of the size, one-dimensionally speaking. The area is not going to quite behave that way, but we're not worried about that right now. So I'm trying to find point P here. So what I'm going to do is find, let's see, what's a good color for P? I think I was using orange. I'm going to call this orange. So if I want to find out this distance, I'm going to multiply 5/6 times -3. All right? That's going to be 83.3% of that number. So if I want to find P's x-coordinate, I'm going to do 5/6 multiplied by the -3. And I'm going to take that and add the x-coordinate of A. All right, so whatever this x-coordinate is, 1, if I add this negative number to it, I will get a new x-coordinate that will be the same as the x-coordinate for P. All right, lots of like weird little moving parts here, I realize. I don't know. We'll figure it out. So let's see, if I simplify this, 3 and 6, those can be reduced. 3 goes into 6 twice and into 3 once. So it looks like -5/2. Oh man, -5/2. Let's do some fraction work here while we're at it, just to make it more complicated. I'd need to get a common denominator. I'm going to multiply that by 2/2. You could have moved into the realm of decimals by now, and I would have been fine with that in this instance. So -5/2 plus 2/2 would be -3/2, or -1.5. So what does that number represent? That is the x-coordinate of P. That means I was off a little bit when I drew this. P is -1.5 x units from the origin, right? Is what we've got. So let's see if we can do the same thing for P's y-coordinate. So pi. So I'm going to have 5/6, man, which by the way, I don't know if I've told you this, that is my least favorite number in the world, right? Like 1/6, that's okay, right? But 5/6, I've got to pluralize sixth. Isn't that disgusting? Sixths? Ugh, it's terrible. No, well, think about it. 2/6 can reduce to 1/3. Right. So I would never say 2/6. I'd just say 2/3. Right? 3/6, that's 1/2. 4/6, 2/3. Because that's not equivalent. 3 repeat. Nah, because I'm a fan of fractions. But I'm just saying the word sixths. Ugh, it's so gross. I can't. I'm done. I can't even say it anymore. I don't even want to look at you. You're the worst number ever. Ugh. All right. So let's see. I'm going to multiply that number by the change in y. And that's going to give me this distance here. Okay? Does that make sense? This blue vertical change. All right. You guys are tracking with me now. I like this. And to that, I'm going to add the y coordinate. Right? So I'm going to take this y coordinate, basically subtract that number, and I'm going to get a new y coordinate. Lots of stuff going on. Yeah, you can turn off your alarm. It'll be okay. Don't worry.
It's my headphones. I don't know what they are.
Oh, man, like Bluetooth ones or something?
Yeah.
All right, you can look for them if you need to. So let's see. 9 and 6, both of those are divisible by 3. So let's see. 3 goes into 9 thrice and into 6 twice. 5 times -3 is -15 halves. Plus, let's see, 6 over 1. I've got to get a common denominator, multiply by dose over dose. I'm sure I've got some adding fractions videos on my YouTube channel if you want to take some time to practice. So let's see, -15 halves plus 12 halves. I just add the numerators, and I'm going to get, no, you didn't, -3 halves. Who would have thought? Man, this one problem has taken 12 minutes to explain. Wait a minute. Did I do something wrong? 3, 15, 12. Oh, okay. Because I was, all right. Because my it's in the wrong spot. It would have been down here. Because it was supposed to be 1.5 units away there. Yeah. Okay. So I'm right. My initial guess of where it was wrong. So not to scale. So the real P is right here. There we go. That's the real P. All right. So -1.5, -1.5. A lot of work to find a single point. And this will show up later on in transformations when we're doing dilations, when we are scaling an image down by an appropriate amount towards a point. This is the way that we would end up doing that. So kind of a lot of components. I tried to throw in, I don't know, some notation just so I could keep track of some things, but don't know if that helps. But the triangles, I think, are the most helpful. Let's see. All right. Whew. Finally. All right. Let's cruise through these ones a little faster. All right. Rise over run. Oh, I can use the same colors. I love it. So the slope of the blue line, to go from this point to that point, I would go up 2 and over, looks like 6, which reduces, because I'm not even going to say that out loud, to 1/3. Do the what? Oh, yeah, you're right. Because, yeah, you remember you're right. So the slope of line A is 1 to 3. Up 1 over 3, up 1 over 3. If we wanted to find the slope by hand, you could have used the formula, the slope formula, m is equal to y2 minus y1 over x2 minus x1. Let's find the slope of the red line using that strategy. Sure, it's easier just for me to count it off the graph, but we'll do this. So the slope of the red line of line B. Well, we'll talk about when I describe the lines parallel. I'll use the names. My bad. What's up, Anthony?
No, you,
A, B, C, D.
the name of the lines are right there.
Right there. So you wanted me to call this like M sub A?
No, yeah, it's called A.
Yeah.
It's the line A.
But that's not A. It's the slope of line A. So I'm using M because we're talking about y equals mx plus b. Yeah. So M sub A? All right. I'll make you guys happy. There we go. Looks kind of like a 9. That's a terrible A. I don't know. So, and then M sub B. So, to find that, I would then use the slope formula. So let's do 2 minus 1, the difference of the y's over the difference of the x's, 3 minus negative 1. So that's going to be 1 over 4, 1/4. All right, but clearly it would have been easier just to go up 1 over 4 and count that. So I won't do that for anymore. I just wanted to familiarize you guys with the formulas. The slope of line C looks like it's going up 2 over 6. Hey, I think I've seen that before. That's 1/3. We're going to look at that in a moment, I'm sure. Let's see. Purple line D. Looks like it's going down. Oh, man, that's going down 8. So the slope of D is going down 8 over, all right, guys, friends, we got this, over 2, which is negative 4. Okay, so now for the question, which lines are parallel? The ones with the same slope are parallel. So A and C are parallel. All right, which lines are perpendicular?
B.
Yeah, B and D, perpendicular lines. Actually, it looks like a cool, like, symmetric mirror right there. Perpendicular lines have slopes who are opposite reciprocals. The reciprocal of 1/4 is 4 over 1. And to opposite it, I would change the sign to negative. So there we go. All right, here we go. Whew. Finally. Here's the problem that I wanted to get to. We're going to practice more like this today with perpendicularity rather than parallelity, which is not a word. Here we go. They've given me the equation of a line. They've given me a point. They are asking me to find the equation of the line that is parallel to this, that passes through that point. In order for me to have the equation of a line, I need to write it in y equals mx plus b form, slope-intercept form. I'm interested in finding out what is m equal to. All right, actually, I'm gonna choose some colors on this. All right, so I need to find m, and I need to find b. Those are the two components, the slope and the y-intercept, that are like the DNA of a line, the thing that describes what it looks like at the end of the day. Now the slope, if it's parallel to this line, how could I find the slope? Well, what is the slope of that line? Trick question. This is the trickiest question. That's why I chose question 16. Notice this. Oh, good save. I like it. Quick. Notice this equation is actually in I don't know, your book might call that standard form. In my book, I wouldn't call that standard form. I would have made that x a positive. But it's not in slope-intercept form. To get that into slope-intercept form, I've got to solve for y. So watch this. So add x to both sides. I will get 2e is equal to x plus 12. How could I solve for y? Everybody by 2. And so I'll get y equal, wrong color. I love using these colors here. I'm going to write this as 1/2 x plus 6. Now, this is not my line. I want the line that passes through P that is parallel to this line. So what do I want to steal from this line? So that line's slope is 1/2, so therefore my line's slope is 1/2. Slop is slope, slop is slope. Yeah, good job there, Isaiah. You were the one that caught the slope of that, right? So if you said the slope was -1, I see why you made your mistake. Hopefully you spotted as well. It wasn't in sloppy intercept form in order to make that happen. Now, I know the slope. I also know a particular ordered pair that I could call x1, y1. If I plug that ordered pair into y equals mx plus b for my equation, it will make that equation true. So what we do is I'm going to plug in what I know and solve for what I don't. All right, I'm going to write this down. So plug in m, x, and y, solve for b. Okay, that's what I'm doing here. So let's do that. So y equals mx plus b, I'm going to have 0 equals 1/2 times my temporary x value here plus b. If I want to solve this now, right, because I've plugged in what I know, I'm solving for what I don't. What's half of 4? 2. And to solve for b, what do I do to both sides? Subtract 2 from both sides. Notice this. I've got b equals -2. I've just found the y-intercept of my line. So what is the equation of my line? Y equals 1/2 x minus 2. Now, notice I didn't plug this in when I wrote the equation of my line. I didn't say this yesterday. I left that generic in terms of x and y because I want this to represent the infinitely many number of ways that x and y would make this equation true. If I plug this in, I'm describing a single point that makes that equation true. So all I do when I plug it in is I plug in the slope and the y-intercept. I leave x and y generic so they represent all combinations of that. All right, thank you for watching, internet friends. That is a long homework video.